Okay, section 5 gives a graph of the function y equals f of x using the following properties. So our first property is limit of x approaching -6, f of x equals 3, although f of -6 is undefined. Our next property is limit of x approaching -3 from the negative side, f of x equals -2, with the limit of f of x equals 5 as x approaches -3 from the positive side. F of -3 equals -2. Our next property is limit of f of x equals infinity as x approaches 0 from the negative side. Limit of f of x equals positive infinity from x approaches 0 from the positive side. F of 0 is negative. F of 0 is 2. Our next property is limit of f of x equals f of 2 equals 0 as x approaches 2. Our next limit is limit of f of x equals 3 as x approaches negative infinity. Our next with limit of f of x equals negative infinity when x approaches positive infinity. So this may be a lot to take in at first, but it's important to just look at what you have and then just lay out some things. Don't connect the dots right away, just lay them out. So first we'll look at as x approaches to -6, f of x is 3. So we go from -6, so 1, 2, 3, 4, 5, 6. We'll just draw a hollow circle at first because we don't know whether it's a solid point or not. However, the next following information is f of -6 is undefined, so at -6 we'll draw a hollow circle, a hollow point, since it's undefined. Next we look at our next property, which is limit of x approaching to -3 from the negative side is -2. So from -3 we'll go to -2. Again, we'll leave it as a hollow point because we don't know if it's defined or not. Our next is limit of x approaching to -3 from the positive side. So from the negative side, this going this way is our first property. The next property is going from the positive side. So from -3 from the positive side, f of x is 5. So from 3 from the positive side of 5, 1, 2, 3, 4, and 5, draw another point, leave a hollow because we don't know if that's defined. Our next information is f of -3 equals -2. Going back to this first point, we can see that f as limit of x approaching -3 from the negative side, f of x equals -2. In this other information of f of -3 equals 2, we can hollow in the point since it's shown defined. We won't connect the dots right away, but let that set in. Our next property is limit of f of x equals infinity as x approaches 0 from the negative side. So from the negative side, we have the limit of infinity going up on either one of these 2 points. Most likely it'd probably be this point since it's more sketchable to go that way. Our next information is the limit of f of x, limit of f of x from positive infinity. Would that be positive? Let me check first. This should be negative. Okay. So the limit from f of x equals negative infinity is x approaching from 0 from the positive side. So from the positive side, it's going down negative infinity. However, we're given a point at f of 0 equals 2. So we can hollow in the point, or solid in the point at f of 0 is 2. This is a crucial information, and these two are just determining points. So we determine whether from the negative side it's going in positive infinity, or from the positive side or negative side it is going negative infinity. Our next property is limit of x approaching 2 of f of x equals f of 2 equals 0. So as the limit approaches 2, so as the limit approaches 2, f of 2 equals 0. So at 2, the point is 0. So we're going to solid in the point. Our last property is limit of f of x equals 3. Limit of f of x equals 3 as x approaches the negative infinity. So from 3, the only point is here is 3, would be negative infinity. So this would go on for negative infinity. Our next one would be limit of f of x equals negative infinity as x approaches positive infinity. So we'll connect the dots in a bit, but we know that as x approaches, so let's see. Okay, so as x approaches negative infinity, it goes on for positive. So it can't be anything from these quadrants, because if it's going down a negative way, it's not positive. So this would be negative in negative direction. So it can't be anything from here. And it can't be anything from here because it's a positive and a negative. So only likely case of it being this quadrant, because this is positive and then negative, but this, positive and positive. Actually, the top one would be positive, positive, the next quadrant would be a positive and negative. So this is most likely our quadrant. So now we can connect the dots. Since these two would be undefined, we won't connect them, but these two we can connect. And since we have limit of f of x, same again, so looking back on this one, since we have limit of f of x equals infinity from the negative side, so from the negative side it goes on for positive infinity as it reaches 0. So for this one we can, but it's not likely to do it, so we'll use our next point of 5. So this will go on for infinity as it reaches 0. This is just 0, 2, we don't have to do anything with that, because as the limit approaches 0 from the positive side, it goes on for negative infinity. So we can't connect any of these points, but we can connect it from 2 and 0. So this will go on from infinity, on from negative infinity as it approaches 0 from the positive side. And our last limit would be the limit f of x approaching positive infinity. Okay, yeah, so this would be positive infinity. It should be negative actually. Yeah, negative, no, positive. Let me check this real quick because I'm not too sure if I wrote down the right increments. Yeah, so this should be negative. So the limit of f of x approaching negative infinity is, or the limit of f of x equals negative infinity as x approaches positive infinity. So once again, we use the quadrants. This would be equaling positive infinity, which won't work. This is going from negative to positive infinity, which won't work again. This is both going negative to negative infinity, which won't work. So most likely cases from positive to negative infinity, which is what we're looking at. So then we can connect the dots from here. So this will go up and then back down, or you can just, the graph will vary depending on what you draw. As long as it fits these properties, your graph should be good. So you can either have your graph going up and back down to infinity, or you can have your graph just go straight down. Not straight down, but curve down to infinity, negative infinity. So you can use either one of those options, but as long as your graph follows these properties, your graph is correct, because as the limit of x approaches negative 6, f of x is 3, but f of 6 is undefined. The limit of f of x equals negative 2 from x approaching, so the limit of f of x at negative 2 as x approaches negative 3 from the negative side. So from the negative side, the limit is negative 2. So, whoops. Negative 3, negative 2. This is from the negative side. So that checks out. Our next would be limit of f of x for 5 as x approaches to from the positive side. So this is going from the negative side, and this is going from the positive side at 5, although it's undefined. Our next property would be the limit of f of x equals infinity at x approaching to negative 0. From 0 from the negative side. So from 0 to the negative side, the limit approaches positive infinity, which is where we get this from. This goes on from positive infinity as it approaches 0 from the negative side. So that checks out. Our next property is limit of f of x approaching negative infinity from x approaches 0 from the positive side. So the positive side of 0, the limit goes on for negative infinity, which is where we get this point from. This goes on for negative infinity as it approaches 0 to the positive side. And then this points out because f of 0 is 2. So that checks out. Our next property is limit of f of x as x approaches 2, f of 2 equals 0. So at f of 2, our limit is 0. Which again checks out. Our next and last properties are the limit of f of x equals 3. So at 3 goes on for negative infinity. So at 3 we go towards negative infinity. So that checks out. Our next one is limit f of x equals negative infinity as x approaches positive infinity. So negative infinity would be either side, but it's going on from the positive direction. So if we had a limit that was negative infinity going to this way, that would be negative infinity to negative infinity, which wouldn't work out. In this case, we would have positive infinity to negative infinity, which won't work out because we're looking for negative infinity, not positive infinity. If we drew going this way, we would have positive infinity to positive infinity, which again does not work out. However, if you go from this quadrant, you're going from positive infinity to negative infinity. So that checks out because your f of x is on the negative side, or your f of x is negative infinity, but your x approaches from the positive side of infinity. So this goes on from infinity to the positive side.